Today we'll be talking about the Marcet boiler experiment of what me and my other two friends did in the lab that day, which is me, Ivan, my friend Mu'azz, and another one, Adam. From the Marcet boiler experiment, we tried to find the properties of saturated wet steam. Alright. The introduction. When the room pressure is constant, available liquid in the room will be heated until a certain condition. When no matter how much heat is given, the temperature will not increase and the liquid will start to change into vapor. The temperature remains constant until all liquids is evaporated. Thus, any vapor under conditions of thermal equilibrium with the liquid from which it originates has a determined temperature at each pressure level. This experiment is to establish the relationship between pressure and temperature values of saturated wet steam. Alright, and the objective, why we do this? Well, for start, we do this to be able to establish the relationship between the pressure and temperature values of saturated steam. The second one is to learn how to compare the obtained saturated temperature and pressure with the steam table data. Now the theory of this. The water inside the boiler is heated up by electrical resistors and starts to evaporate. As more water changes phase from liquid to vapor, more vapor accumulates inside the boiler vessel and increases the pressure imposed on the water surface. This pressure build-up tends to increase the resistance faced by liquid molecules as they change to vapor, consequently increasing the saturation temperature of the remaining liquid or pure substance existing as a mixture of two phases. The Clapeyron relationship relates the pressure, heat, and expansion during change of phase provided the two phases are in equilibrium. The Clapeyron relationship is, and you can see the equation there, dt over dp equals to tvg over hfg. Okay, from the theory, the apparatus we use to conduct the experiment, is the Marcet boiler. You can see that? Marcet boiler. Alright, the procedures we had. The first thing we did is we set up the boiler for heating and cooling process. As in we fill in the water memang there ready We just switch it on and wait. While it's on, the resistor inside the Marcet boiler heats up water. And once the air has been fully purged from the boiler, as in once all the water there boils, turns to steam, we see the steam expelling from the Marcet boiler. After a certain time, when the steam is all out, as in we assume that there's no more air inside, we close the valve. Then we start to take the readings of the temperature and relative pressure at intervals of 1 bar under a relative pressure of 7 bar. Then we repeat the steps for cooling. As in when the pressure reaches 7 bar, we switch off the resistor. So as it cools down, we also take the readings as well. And then the follow-up is we process the results and analyze them. Okay. Now for our results. We must start. Boom. B. Did I press play? Yes, I did press play. Okay. Never mind, I'm sorry. Alright, the results as you can see there. This is what we were able to obtain from the experiment. Cathode pressure 1 bar is equal to 100 kPa. Alright. Then the equation there. What we did, find all the equations of that. Experimental error, how? And this is our graph, what we were able to obtain. You can see there 0 to 900. It is at each 100. The temperature in degrees Celsius and the pressure is in kPa. I forgot that, I'm sorry. Alright. And the other one, which is dt over dB, the VS pressure chart for theoretical and experimental results. You can see it. Alright. Then on to our discussion. So what we discussed and what we found out is based on the temperature versus pressure graph and the result table, it can be seen the relationship between the pressure and temperature is directly proportional. The same can be said when the water is cooling. The lower the saturation temperature, the lower the pressure. The percentage of error range from X% to X%. Okay. Sources of error are measurements or reading accuracy, temperature and the pressure of the room, the stability of the materials and calculation. Air will first be expelled from the boiler prior to measurement recording. Because if the air is not expelled correctly, the correct equilibrium measurement between the steam and boiling water will not be obtained. Due to the partial pressure of air, a lower water temperature will be required to raise the pressure. The application of Marcet boiler would include water boilers, gasifier, power plants, and also for cooking utilities. For example, you can see there the pressure cooker. Now, the percentage range of error is you can see ranges from 1.54% all the way to 50%, and you can find average of experiment error is 20%. Sorry, I forgot to put it in. Conclusion. In the experiment, it shows from the table and graph that as the saturation temperature increases, the pressure will increase. It is raising some negligible faults. This experiment can be considered successful. To prove the results of the experiment though, It should be carried out at the room temperature, switching off all air conditioners, and also by repeating the experiment and taking the average value. If some insulation were kept on the master boiler to reduce heat loss, the experiment will be more accurate. The possible applications of the experiment can be applied in machinery that requires high temperatures. For example, water boiler, pressure cookers I said before, power plants. All the above devices raise the temperature of a substance to high temperature. The limitation to this would be the danger that comes together with high pressure. If the container is not strong enough to handle the high pressures, it could explode. Yes. And that is the conclusion to our experiment. Thank you for staying with us, and goodbye. Bye bye.